Hi, we're Covalent Girls. Have you ever wondered why does an apple turns brown after you cut it? Well, we are here to explain the dark side of the apple. Problems description. It is well known that in the air media a fresh cut made on an apple turns brown with time. What are the reasons for the change in color? Experimentally research the dependence of the browning rate upon at least five physical and chemical factors. Suggest the hypothesis explains the observed dependencies. Find out the most effective chemical inhibitor of browning. Propose the effective chemical anti-browner which can be used without loss to the nutritional status and to the taste of the apple. So our considerations are that the apple must have protection from oxygen, which is the main cause of this browning, proposing the most effective chemical anti-browner, and the apple is safe to eat for a healthy average person. Objectives: find out the best way to retard the browning of an apple without affecting its nutritional status and taste. This keeps the apple in good condition for an extended period of time and maintain its visual appeal for an average quality apple. Components of an apple. Apples consist of phenols that protect against fungi and bacteria. Apples are an excellent source of carbohydrates, with glucose, fructose, and sucrose being the most abundant. Malic acid is the dominant organic acid in apple fruits, accounting for up to 90% of the total organic acids. Polyphenols are the largest group of secondary plant metabolites in apple fruit. They are responsible for the fruit's color, flavor, and taste. Chemical factors. Enzymes affecting the oxidation of apple. Effect of quinones and oxygen. The polyphenol oxidase PPO affecting oxidation. Relationship between phenolics and apple. Apple turns brown because of enzymatic browning, and this process requires oxygen, a special enzyme called polyphenol oxidase (PPO), polyphenols, also known as phenolic compounds. These are organic molecules that contain at least one hydroxyl group linked to a hydrocarbon ring. Physical factors. Other factors such as thermal factors can also affect oxidation. Additionally, oxidation can be influenced by dough treatment, surface treatment, and thermochemical treatment. And now that we already saw what are the components involved in the browning, we can tell you exactly why this happens. When you cut an apple, you are damaging its cells, and now that they are exposed, they have contact with air, which contains oxygen. We remember that to make an oxidation, we need oxygen, right? So the polyphenol oxidase (PPO) oxidases the phenols, and to all that reaction, they give us melanin, the same one that pigments our hair or skin color. So the melanin is the one that pigments the apple. Why does this happen? Because when their cells are damaged, they want to protect the apple from wherever it's like a threat, like bacteria or fungi. So they make all this process just to make like a layer to protect the apple where the damaged cells are. The chemical factors tested to prevent browning, the addition of some organic acids that function as antioxidants such as citric acid from lemon, malic acid, and acetic acid. These are like some ways that we can prevent browning. So that is useful for our solution. Our hypothesis is the presence of acids is more effective for anti-browner than physical factors, because a physical solution might conserve better its properties, but the effect wouldn't last long. So we expect to retard the browning by using acids that work like active antioxidant agents. Solution. Oxidation can be prevented or slowed down by not allowing oxygen to get to the surface of the fruit. To accomplish this, you can cook the food, which destroys the enzyme. It is also possible to prevent browning without cooking by covering the fruit, preventing air from reaching the fruit, or by lowering the pH on the surface, making it more acidic. So, our solution is to wrap the apple in a certain plastic wrap to avoid contact with oxygen, but with the difference that the plastic will be covered with lemon acid that helps retarding the browning. So we would be using two of our solutions but mixed in the same one, and that would give us the best result. And the conclusion is the citric acid with the plastic wrap does not affect the nutritional state of the apple and only slightly change its taste. Once the wrap is removed, the apple is edible. The presence of citric acid helped prevent and significantly delay the browning of the apple. This is due to the antioxidant properties of citric acid, which helped combat the oxidation and darkening of the fruit. It is important to consider other factors, such as the concentration of citric acid used in storage conditions, to obtain more precise conclusions about the effect of citric acid on an apple oxidation. Well, that would be it. Thanks a lot. See ya.